Hello and welcome back. Today we're going to be looking at product law and quotient law. So what that is really going to be looking at is multiplying powers and dividing powers. So let's jump right into it and look at exactly what we're going to be doing here. So patterns arise when you multiply powers with the same base. Now, a big importance here is that we're talking about the same base. It has to be the same base in order to combine these powers together. Now, when I'm talking about that, the base here is 5, the base here is 5. So that means it's going to follow the product law because the bases are the same. So let's see what this looks like. We'll be writing out the repeated multiplication as 5 times 5 times 5 times 5, which represents the 5 to the power of 4, multiplied by 5 times 5 to represent the 5 to the power of 2. Now, when it asked us for product as a power, our base is 5. And what we do here is we're adding our exponents together. So you have 4 plus 2, which creates 5 to the power of 6. You could also look at it as adding these up. So you have a total of 6 of the 5s here that you're multiplying by itself. So your total for the product as a power is 5 to the power of 6. In this example here, we have 3 as our base, and if we were to write 3 to the power 2 as repeated multiplication, you have 3 times 3 multiplied by 3 to the power of 4, which looks like 3 times 3 times 3 times 3. So in total here, we have 1, 2, 3, 4, 5, 6, or you could look at adding your exponents, the 2 and the 4, and you'll get 3 to the power of 6. In our third example here, pay attention to the brackets because we want to make sure that our final answer has these brackets as well. Because in the earlier lessons, we saw the difference between having the brackets and having the negative on the outside of the brackets. So let's write this repeated multiplication out. For negative 5 to the power of 3, it's going to be negative 5 in brackets 3 times, and multiplied by negative 5 to the power of 3, so multiplied by negative 5 to the power of 3. And if we add these up, we have 1, 2, 3, 4, 5, and 6. So we have negative 5 in brackets to the power of 6. Next it says, describe any patterns you see in the table. Well, one thing that should jump out to you and that I explained at the beginning was that the bases are the same. So in order for this product law to work, the bases must be the same. The next thing that you saw us doing was that we were adding the exponents. So whenever you're following the product law and you're multiplying powers with the same base, you're adding the exponents together. Last thing that should have stood out to you when we were doing the repeated multiplication was the exponents tell us how many times the base is multiplied. So what the exponent law for a product of power is to multiply the powers with the same base, you add the exponents. For example, a to the power of m multiplied by a to the power of n equals a to the power of m plus n. So you're taking the exponent m, and you're taking the exponent n, and you're adding them together because it's a multiplication of the same base. Now let's put this into practice with some of the examples here. Write each product as a single power, then evaluate if possible. Now, I'm not going to do all of the questions here, and I'm going to leave some of them for you to go and check your answers in the class OneNote afterwards. Let's start off with A. If we have 6 to the power of 5 multiplied by 6 to the power of 4, our base is 6 and our exponents are 5 and 4. So you'll be adding 5 and 4 together. Now this gets us 6 to the power of 9. Because it says evaluate if possible, we're going to see what 6 to the power of 9 equals. Now that'll give us 10,077,696. For B, I'm going to leave for you to complete and for you to check your answers in the OneNote. For C, we have -7 in brackets. Again, remember that the brackets are important here. Where the brackets are positioned in terms of where the negative is has a drastic effect on your outcome. So, -7 in brackets to the power of 5 multiplied by -7 in brackets to the power of 3. So our base is -7 and our exponents are 5 and 3. So 5 plus 3. This gets us -7 in brackets with an exponent of 8. Now because we can evaluate this, we get an answer of 5,764,801. Again, you're using your calculator to find this. For D, I'll leave for you. For E, though, I want to draw some attention to what's in between here. This time, we've positioned an addition question here. So we have addition in the middle. Now, this means that you cannot combine your powers here. What you have to do is write as a single power. So we need to evaluate what 2 to the power of 5 is and what 2 to the power of 4 is. Well, 2 to the power of 5 will get us 32 plus 2 to the power of 4 gets us 16. Now to evaluate this, you have 32 plus 16, which gives us 48. So just because we are working on this page, don't assume that they're all going to be multiplication questions. Please pay attention to your symbols. For example, F, we have x to the power of 4 multiplied by x to the power of 8. Now you'll notice that we're dealing with variables. Now variables means there's a letter involved, and you're going to see how that affects what our outcome is. So our base in this situation is x, and our exponents are 4 and 8. So 4 plus 8. This results in x to the power of 12. Now, because we don't have any more information to go on, we cannot evaluate it. So this is where you're going to leave it. So you cannot evaluate. For G, I'm going to leave for you to complete and check in the class OneNote. Next, we're going to be looking at quotient law. difference now from product law to quotient law is that we're dividing powers. Now again, it's important that we still have the same base when we're looking to solve for the quotient law. In the first example here, we have 5 to the power of 6 divided by 5 to the power of 2. First thing it asks us to do is write out the repeated multiplication. So 5 to the power of 6 means 5 multiplied by itself 6 times. So you're going to write that out across the top. Then you're dividing it by 5 to the power of 2. So 5 to the power of 2 is 5 multiplied by itself 2 times. In this situation here, we're going to be subtracting the exponents. So for product law, you're adding the exponents together. For quotient law, you're subtracting the exponents. So what we can do here is cancel off above and below the division sign. So this can cancel off and this can cancel off. And we're going to be left with 5 to the power of 4. 1, 2, 3, 4. 5 to the power of 4. In the second example here, we have 3 to the power of 4 divided by 3 to the power of 2. 3 to the power of 4 is 3 multiplied by itself 4 times, divided by 3 to the power of 2, which is 3 multiplied by itself 2 times. You can cancel out above and below the division sign. And what we are left with is a base of 3 and an exponent of 2. You could have also looked at it as 3 to the power of 4 subtract 2 equals 3 to the power of 2. For the third example, we have brackets involved, so remember to keep your brackets as you're writing this out. And we have negative 5 to the power of 4, so we have to write out negative 5 in brackets 4 times, divided by negative 5 to the power of 3, which we have to write out 3 times. You can cancel off, and you're left with negative 5, and it would be to the power of 1, or just negative 5. So describe any patterns you see in the table. Well, a lot of the patterns are going to be the same that you found for product law. The bases are the same. The difference here, though, is instead of adding the exponents, you're subtracting the exponents. And just like the product law for the repeated multiplication, the exponent tells us how many times the base is multiplied. So to sum up the exponent law for a quotient of a power, to divide powers with the same base, subtract the exponent. So a to the power of m divided by a to the power of n equals a to the power of m subtract n. So you're subtracting your exponents. Just like I did for the product law, I'm going to do some of these example questions and leave some of them for you to complete and check in the class OneNote. When looking at example A, we have 8 to the power of 7 divided by 8 to the power of 4. Our base is the same, so we're good to follow the quotient law here. So 8 is our base, 7 subtract 4 will be our exponent right now. 7 subtract 4 gives us 8 as our base still, with an exponent of 3. Now, because it says to evaluate if possible, we have to find out what 8 to the power of 3 is, which gives us 512. For B, I'm going to leave for you to do. C, because it has the negative in the brackets, I want to go over again. So remember, the brackets have to stay all the way through the process here. Negative 9 in brackets to the power of 10 divided by negative 9 to the power of 6. So you have negative 9 to the power of 10 subtract 6 gives us negative 9 to the power of 4. Again, we're going to evaluate this, and this equals 6,561. D, I'm going to leave for you to do. In E, we're going to look at what's wrong here. Well, we have a 3 and we have a 2. Notice that the bases are not the same, so we're not going to be able to follow this quotient law. So the only thing we're able to do here is evaluate for the numbers that we have. What we have to do is figure out what 3 to the power of 5 is, which gives us 243 divided by 2 to the power of 4, which gives us 16. Now, finding out what 243 divided by 16 is, well, it will result in 15.1875. So, important thing to remember here is we cannot write as a single power because the bases are different. For example F, we have x to the power of 9 multiplied by x to the power of 3 over top of x to the power of 2. Now, first we have to notice that we're dealing with a variable instead of a value. And the next thing we have to think about is our order of operations. Now, because this is on top of the division sign, we're going to treat this like it's bracketed, and we're going to have to solve for this first before we can solve for the division part. Now, x to the power of 9 multiplied by x to the power of 3 will give us x to the power of 9 plus 3 over x to the power of 2. So this means x to the power of 12 over x to the power of 2. Well, x to the power of 12 divided by x to the power of 2 means we have to follow the quotient law now, and we're going to go back to subtraction. So x to the power of 12 subtract x to the power of 2 equals x to the power of 10. And again, we can't evaluate this because we don't have any value for x here. So we'll just put down a note that we cannot evaluate. For example, G, I'm going to leave for you to complete and go over and check in the class OneNote. The last part of today's lesson is looking at using the order of operation when we're going through the exponent laws. It says to simplify and then evaluate each expression. First question we have is 6 to the power of 2 plus 6 to the power of 3 multiplied by 6 to the power of 2. First thing we have to think about is order of operations. We're following that BEDMAS, so we're looking for brackets first. There's no brackets. In this situation, we'd look for exponents. Are there any exponents that we can combine together? Well, we're not going to combine this part because it has the addition in between here, but we can combine the 6 to the power of 3 multiplied by the 6 to the power of 2. So first you write out your 6 to the power 2 because that's continuing on and we're not doing anything with that yet, plus 6 to the power of 3 plus 6 to the power of 2. So we're adding the exponents. So you want to add the exponents. So this will give us 6 to the power of 2 plus 6 to the power of 5. The next thing that we want to look at is simplifying this. So I'm going to just put down a note of simplify, which means we're going to evaluate for what 6 to the power of 2 is and 6 to the power of 5 is. Well, 6 to the power of 2 will give us 36, and 6 to the power of 5 will give us 7,776. We're going to continue to evaluate here, and we're taking 36 plus 7,776, and we get 7,812. So what we did is we added it together. For example B, we have negative 10 in brackets to the power of 4, and inside the square brackets, we have negative 10 to the power of 6 divided by negative 10 to the power of 4, and then we have subtract 10 to the power of 7 at the end. The first thing that we want to look at is what's inside the brackets. And because it's division, we know that we're going to be subtracting the exponents. So first thing is I'm going to write down the negative 10 to the power of 4 because we're not doing anything with that yet. And we want to pay attention to what's in the brackets, which is negative 10. And we have 6 subtract 4, closing those brackets. And we're not doing anything with this subtract 10 to the power of 7. So what we're doing is we're subtracting the exponents. So when we subtract the exponents, you're going to have still the negative 10 to the power of 4 in brackets, negative 10 to the power of 2 because we did our subtraction, subtract 10 to the power of 7. The next thing that we want to look for is our multiplication because we just completed our division. Our next thing is our multiplication, which will be the negative 10 to the power of 4 multiplied by the negative 10 to the power of 2. So I'm just going to write down, we want to add the exponents because we're looking at a multiplication. So if we add the exponents, we're going to have negative 10 to the power of 4 plus 2 subtract 10 to the power of 7. Well, we're going to simplify this, and we're going to have negative 10 to the power of 6 subtract 10 to the power of 7. To evaluate this, we're going to figure out what negative 10 to the power of 6 is, which is 1 million. So 1 with 6 zeros. Subtract 10 million, which is 10 to the power of 7. So 1 million subtract 10 million gets us negative 9 million. and that would be our final answer. For example C, we have 2 to the power of 5 plus 2 to the power of 3 divided by 2 to the power of 2. In this situation, no exponent law can be used because we have to first solve for our top portion, but we have addition in there, and then we have to solve for division portion. But because no exponent law can be used, all we're left with doing is evaluating. This means that we have to solve for 2 to the power of 5, which is 32, plus 2 to the power of 3, which is 8, over 2 to the power of 2, which is 4. So we're evaluating for those. Next, we want to go to 32 plus 8, which gets us 40 over 4. And our last thing to do is 40 divided by 4, which equals 10. Now this completes our lesson for today, and if you have any questions, please make sure you ask me in class or you send me a message over Teams. Have a great day.